Hello, everyone. Thank you for joining us in the second Hack3D webinar. For today's presentation, I've invited Nishant, who was involved previously in Hack3D in the previous years. And today he's going to talk to us through the previous year's competition, as well as share some insight on his participation. So Nishant, I'll give it up to you to introduce yourself. Thank you so much for joining us.
Yeah, for sure. Hello, everyone. Hope you're all doing well. Yeah, so as Gary said, I have been given some time to sort of explain my experience with Hack3D and walk through some of the previous challenges that I'm quite familiar with. I will share my screen. Sorry, give me a second.
No worries. Nishant, if you can also do a brief introduction of yourself and how you were involved in Hack3D, that would be great. So we can all get to know you a little bit.
Yeah, so I have that set up. So yeah, are you able to see my screen, Gary? Okay.
Yes.
So this is just an overview of how I want to present today. And so I'll give an introduction of myself and a little bit of background of how I was associated with Hack3D. And then I want to go through the preliminary challenge and explain it. And then go through the preliminary challenge solutions and the final challenge and final challenge solutions. This is from 2019. So as a little introduction to myself, my name is Nishant Aslani. I am a computer engineering undergraduate at New York University, Abu Dhabi. I was, in the summer of 2019, I was in the CMML working with Professor Gupta and Gary as well on some research. I'll go over what the research was. But through that, we were able to incorporate some of the ideas as part of the Hack3D 2019 preliminary and final challenges. So I'd like to go through and talk a little bit about what we were doing here. So I was working with my another colleague of mine, Michael Linares, and we were working on this system to verify the authenticity of models in the additive manufacturing chain, but especially in the software side of things. And so here's a research poster to describe what we were working on. The idea was we wanted to be able to detect whether certain 3D models had been tampered with along in the chain. From production all the way up, and from the design all the way up to the physical manufacturing of them. And the idea was to be able to show this file back to the designer and decide whether somebody had removed something that would cause a critical failure or added an artifact of some sorts that would cause a critical failure. And the way we approached this was adding on from previous work. And so previous work had focused on embedding a QR code into a piece. We took that idea and sort of molded it and started working with data matrices. As you can see here, this is an example of a data matrix here. And what we had done was we took the data matrix because we found it to be a bit more dense, so you could store a bit more information in it with a smaller form factor. And the idea was to store this 2D code as a 3D code. So what we did was we exploded this into 3D space and embedded it within our within a product such as this. You can see a screw with the code inside. And if you look at it from the correct angle, as you can see over here on the right side, or over here, you can actually make out the data matrix. And we'll see this in some of the other challenges I'll discuss. But the very simple idea of the encryption and verification procedure was we would shuffle I don't want to get into too much detail because I don't want to take the focus away from the challenges, but the idea was that it was authenticating, which meant that the information to verify whether the product was tampered with or not was stored within the model itself. And so you would really need nothing else other than the actual model to check and see if somebody had tampered with it. And so these are the very basic steps that we went through. This is the sort of description of our system. But this was our work over the summer, and we extracted some of these ideas to design the Hack3D challenge. To sort of explain our approach to the Hack3D challenge, to preface it, Michael and I, we were focused on providing a challenge that wouldn't bog the participants down into tedious details. Rather, we wanted something that, you know, a mechanical engineer, an electrical engineer, a computer engineer, anybody could really approach from various different angles and be able to come up with some sort of solution. There was no perfect solution to our challenges. It was so that we wanted to see the creativity of the participants. So with that in mind, I'll go ahead and start discussing the preliminary challenge. This is what the preliminary challenge website looked like, the qualifying round. We would usually have this, the wise duckling as a hint up at the top. But essentially, this was the problem statement, and we provided participants with a G code. And we wanted them to repair this G code or repair whatever they found in this file. So I've downloaded this file here. I'm just not sure if this is in view. Are you able to see my folder?
I'm still viewing the qualifying round webpage.
Okay, that's odd. Okay, let me pull that out. I will reshare. Enter desktop. Are you able to see my folder now?
Yeah.
Okay, perfect. So this is when the G code was downloaded. This is the file you would essentially receive zipped. I've unzipped it, but this was the 3 chess pieces. Here, I'll open up the file. And the idea was there was one quote unquote correct file. So what we had done was that we had taken one of these 3 chess pieces and converted it into G code. So this is the code that the 3D printer would be able to look at. And we had taken the top off of the piece. So if the top was taken off, you would only be able to see the bases. And as you can see here, the bases are essentially identical. So there is no direct way of being able to tell which piece we had chopped the top off of and provided to the participants. And so I'll share what the damaged G code looked like here. So this is a cool tool we found online. It's called NC Viewer. I think it's valuable to find free and open source software. I'm not sure if this is open source, but yeah. So if you opened up the broken or damaged G code file, you would see this rather unsuspecting bottom half of one of the chess pieces. And so the challenge was to recreate the rest. And I think the fantastic thing with the challenges was people came up with creative ways to do this. But I want to focus on one of the things we had hidden inside. So if you zoomed in a little bit, you would notice that there's some odd artifacts in here inside the G code. And this was one of the possible solutions for the challenge. But what I want to do now is go through one of the other solutions that I thought was quite creative and did not necessarily rely on the artifacts that are found in here. So this was a couple students from Arizona State University. And they were able to use some creative thinking and some of the information within the damaged G code file to be able to determine what the correct top half of the chess piece was. So as you can see here, they picked up on the fact that all of the bases were the same, and that there are the three possible tops that they could replace or fix the G code with. And they were able to reproduce all three pieces because they were rather symmetrical. They were symmetrical pieces, so it was relatively simple to recreate from the image. And they finally realized that it was the G code of the queen model that had been chopped off from the top. And I think that was creative because they were at one point able to look at the damaged G code file and notice that some of the header information, so that's one of the themes we had, was with certain attacks, you can recognize that there's certain hidden information that if you know where to look, you're able to extract information that not necessarily was provided to you to begin with. So they were able to extract a complete height of the original G code, which we had not removed from the damaged G code file. If I can pull up the damaged G code file, that would make more sense. So this is what a damaged G code file looks like, right? We used Slicer as an open source slicer to generate this G code from the STL files. And so they were able to look at the information in the header file up here and determine the original height. And from that, they were able to recognize that it was most likely the queen piece that was the solution. So another solution I wanted to go through was from the NYU Abu Dhabi team. And they were able to recognize that there was some hidden artifacts inside the chess piece. And they were working towards realizing that this was actually a QR code that was hidden. So had they successfully extracted it, and I'm not sure, but I think you can sort of, if you're familiar with what QR codes look like, which is essentially figure A here, you can sort of tell the outline over here that this is a QR code. And so had they successfully extracted this, removed some of the artifacts and successfully extracted it right here, as you can see, they got quite close. If they scanned this QR code, they would have actually arrived at this file here, and also a drive folder that would lead them to the other half of the QR code, which they would just have to paste into the original file, and then they would have the full queen G code ready. So that was sort of the couple approaches that we saw for this first challenge over here. Are we doing questions towards the end, Gary, or?
Yeah, we have time. They can type their questions in the chat. We can answer some questions.
Yeah, sure. So I'll move on to talking about the final challenge. That was so five. I believe it was 5 participant teams that were with the final challenge, or joining us for the final challenge. And so here are some of the objectives of what we wanted to accomplish with this. We wanted to introduce the participants with the very basics of graphics programming and file forensics. We also wanted to touch upon reverse engineering, which was also touched upon in the previous challenge, as you saw. And we also wanted to include some of our research that I showed earlier with this poster here, and I'll point that out as we get to it. And again, we wanted to allow for creative freedom and avoid something, some cookie cutter solution, right? So there are a couple expected methods that we had, but we were also hoping participants would come up with their own sort of challenge, own sort of approach. This is what the final challenge file looked like, or website looked like. And I'm not sure if you guys, I mean, this is completely gibberish, but the hint up here from the wise duckling was supposed to let the participants know that this was a Caesar cipher. And so if we take this and we paste it into a Caesar cipher website, we get to see, oops, I missed a letter there. You'll see the actual challenge written over here. So that was one of the earlier playful, cheeky challenges to start the competition off. But essentially down here, you'll see that what the deliverables were. So the challenge was essentially providing the students with this file here. And I'll open that up. I have that open here in Gmesh. So it's not immediately clear, but this is an adapter of sorts. So this was designed here in Onshape like this. Oops. Yeah. So this is the original file. And as you can see, it's the female adapter, and you can attach, you can design a file that would, or design a piece that would essentially act as the male adapter and fit here. And so that was essentially the challenge, was that we'd given them an STL file and with no other information, just this STL file that you're seeing here. And we wanted them to design for the male adapter, given no specifications of the dimensions here or anything. And so, but again, as you notice here, and I think you may have seen it in the very beginning, was that there is a code in here. And so you would come across this code if you experimented by looking at it through a couple different software. I know if you look at the immediate STL viewer online, so for example, if I go to STL viewer and I pull up this file, it's not immediately obvious that there's something inside. So that was also part of the idea, was to explore with a couple different pieces of software, and you come across this. It's a little tough to scan directly like this, and so also part of the idea was to have them extract these, just this code inside, have them extract this code inside and then be able to scan it. If you try to scan this now, it won't work very well, because it's just got too many artifacts and a missing, I guess, too much gap in between these spheres. But yeah, this is harkening back to the research Michael and I conducted over summer at the CMML with the 3D data matrix. As you can see, this is actually, that only works if you look at it from a certain angle. But otherwise, if you look at it from elsewhere, it just looks like random noise that's inside your 3D piece. So that was that. And so the idea was, going back to this hint here, we released scheduled hints throughout the competition to sort of nudge participants towards going in a certain direction, in one of the expected methods directions. But the idea was, the theme here was, I'm opening this website here. So this STL format. And if you look at the hint, it says, if you wanted to hide something in your STL file, what is a potential place? If you think like if you're thinking in a maybe a malicious way, or maybe in a way where you just want to communicate with somebody with some hidden code, where would you hide this information? And so we provided a link to the STL format here. And so the idea was, this is all important information, right? This is your normal vector and XYZ points to draw out your triangle for the STL file. But up here, there's 80 bytes of ASCII information that has no data significance. you could put anything in here and it would not affect your overall file if you've generated your file correctly. First 80 bytes hold no significance. And so that was part of the hint, is that if you looked at the actual final challenge STL file, so I believe I've got that opened up here. So this right here, the first 5 lines, oops, yeah, these first 5 lines, they mean nothing to the STL file. And so if you did a little bit of exploration and ran this through an ASCII viewer, so let's try that actually. ASCII to text. Oh, this actually gives you, no, that's the wrong one. Okay, I don't have the thing pulled up, but essentially, if you were to run this through the right software online, this is essentially ASCII code, right? With the incorrect spacing. So if you looked at it, these would convert to letters, and you would get a hidden message in here. And then if you also scan the data matrix that I showed here in the Gmesh, if you also scan this, these 2 pieces of information would actually lead you to a server we had set up that had this file that you see here, which specified the dimensions of the female header. And so based off of that, you would actually be able to design a male header for the challenge. And so here I'm pulling up images of what people finally ended up designing. So here's let's see this. So these were some of the final designs that people were able to make. If you look at the Team Bagel in the back there, they were able to design a male pin that fit quite snugly with the female pin there. And same here with Snack AD, Team Snack AD. Other teams had slightly different solutions. For example, this team here sort of blocked around the entire female pin, which was, I mean, it was a solution. It was just not up to specifications that how we had described we would like the male header to sort of function. But yeah, so two or three of the teams were able to, solve the challenge through, well, Snack AD, I believe, was able to solve it through the data matrix as I just described. And the Team Bagel was actually able to brute force it and then reverse engineer and redesign the male pin that way. So yeah, that was an overview of the 2 challenges. I'm happy to take questions about the challenges or talk about the philosophy of the challenges.
Yeah, thank you, Nishan. If you have any questions, feel free to type them in the chat. And I think Nishan provided a really good overview and explanations of some of the ideas that go behind our research in additive manufacturing security and in the whole additive manufacturing digital process with all the different file types. Nishan helped us explain, where are the different areas that we can hide codes or modify the file to kind of add in a security feature, and how that eventually developed into a Hack3D competition. So here, I think we have a question. Is it always about finding hidden codes? When we think about, additive manufacturing security, it might not always be a hidden code or something hidden from plain sight, but there are, security methods where we can utilize barcodes or watermarks where, if you think about a watermark in a PDF, it's something visible, but it also adds a security layer because you can't easily reproduce it or EDU watermarks or maybe barcodes on packages where it can authenticate the part or the product, but it doesn't necessarily remain hidden from the user interface. So.
If I could, are you able to hear me? Sorry, I don't know if my mic is, yeah, okay. I just want to actually share this very interesting graphic that I think really represents, let me know if my screen is shared. Are you able to see it, Gary?
Yes, I see. Yep. Yeah.
Yeah. So I think this is actually a fantastic graphic, and this is to the point you were making, Gary. This is an overview of the additive manufacturing chain, and if you think about it, there's so many potential places somebody could sort of make an attack, design an attack, malicious, or there's so many ways you could actually, so many areas you could actually add security to if you're on the other side where you're actually making preventative measures for these potential malicious acts, right? And I think this is the beauty of Hack3D is that every year, the challenges I described, they're not necessarily going to carry over. The ideas aren't necessarily going to carry over precisely. The details of them are not going to carry over year to year because there's just so much potential and so many areas and so many ideas, even within a certain area that could be explored. So with our research that I was referring to earlier over the summer, we were looking at sort of in the computer aided design area, sort of looking for tampering in this software area rather than the more manufacturing area. But yeah, again, that's again the beauty of Hack3D is that we're exploring all of these potential areas of discovery, really.
Yeah, thank you, Nishan, for sharing that. I think that hopefully it clarifies a lot of the approaches that can be taken. Okay, I don't see any more questions. So I think that pretty much concludes our webinar today. Thank you, everybody, for joining us. And one last thing is for the Hack3D competition, for the qualification round, next Friday, October 16th is the deadline. So keep that in mind, and I hope to encourage everybody to submit their report as well as their file. And looking forward to seeing all of your submissions. Thank you so much for joining this webinar. Thank you, Nishan. Take care, everyone. Bye-bye.
Thank you.